Welcome to Touring Globe. Here comes a travel to Mars, a comprehensive guide. Traveling to Mars is the pinnacle of human exploration, with preparations underway to make this monumental journey a reality. Though still in the future, various space agencies and private companies are developing the technologies needed for a trip to the Red Planet. This guide provides an overview of what such a journey might involve, including the mode of transport, carriers, and estimated costs. 1. Pre-launch preparation, psychological and physical readiness. Mental health. Preparing for a journey that spans years, with isolation, confined spaces, and limited communication, requires psychological resilience training. Physical conditioning. Astronauts must be in peak physical condition to withstand the rigors of space travel, including microgravity and radiation exposure. Training and simulations. Simulated missions. Training will include Earth-based simulations that mimic Mars conditions, such as the high seas habitat in Hawaii. Spacecraft operations. Astronauts must learn spacecraft systems, spacewalk procedures, AVAs, and emergency protocols. Spacecraft and mission planning. Spacecraft selection. The journey will likely utilize a spacecraft designed for deep space travel, such as SpaceX's Starship or NASA's Orion, equipped with life support, radiation shielding, and autonomous navigation. Mission duration. The round trip to Mars, including time on the planet, could take approximately 18–30 months, depending on the mission plan and launch window. Health and safety precautions. Radiation protection. The spacecraft will need advanced radiation shielding due to the high exposure levels beyond Earth's protective magnetosphere. Life support. Life support systems must be redundant, ensuring a steady supply of oxygen, water, and food throughout the mission. 2. The journey to Mars. Mode of transport. Spacecraft. SpaceX Starship, designed for long-duration space travel, capable of carrying 100+ passengers, with advanced life support and in-situ resource utilization capabilities for refueling on Mars. NASA's Orion. Part of the Artemis program, Orion is designed for deep space missions and may be used in conjunction with a lunar gateway for a staged approach to Mars. Propulsion. Chemical propulsion. Currently the most reliable method, using rocket engines that burn liquid oxygen and methane or hydrogen. Travel time, till 6–9 months one way. Nuclear thermal propulsion. A developing technology that could shorten the journey by providing more efficient thrust. Travel time, till 3–4 months one way. Carriers. SpaceX, the leading private company developing Mars travel technology with its Starship, which aims to make Mars colonization feasible. NASA, partnering with international agencies and private companies to develop the technologies needed for Mars exploration. Other private companies. Companies like Blue Origin and Boeing are also working on space travel technologies that could support Mars missions. Estimated costs. Individual ticket cost. Early estimates for a seat on SpaceX's Starship have ranged from $100,000 to $500,000, depending on the scale of the mission and technological advancements. These costs may decrease as the technology matures and becomes more accessible. Mission costs. SpaceX Mars mission. Estimates for a full Mars mission range from $2 to $10 billion, depending on the scale and duration. NASA's Mars mission. NASA's plans for Mars exploration could cost upwards of $20 billion, factoring in research, development, infrastructure, and the mission itself. Deep space travel. Life in microgravity. Spend several months in a microgravity environment, requiring daily exercise to maintain muscle and bone health. Communication. Expect communication delays of up to 20 minutes each way due to the vast distance between Earth and Mars. Daily routine. A structured daily routine, including exercise, maintenance tasks, scientific research, and personal time, is vital for maintaining health and morale. 3. Life on Mars. Habitat and living conditions. Martian habitat. The habitat will be a pressurized, temperature-controlled environment, providing oxygen, water, food, and protection from radiation and dust storms. Daily life. Activities include habitat maintenance, scientific experiments, food preparation, exercise, and communication with Earth. Martian day. Adjust to the Martian day, which is approximately 24 hours and 39 minutes long. Scientific research and exploration. Surface exploration. Conduct AVAs to collect soil and rock samples, study the Martian landscape, and search for signs of past life. Robotic assistance. Utilize rovers and drones to extend exploration range, gather data, and transport equipment. Communication with Earth. Send research data and updates back to Earth, managing the delays due to distance. Challenges and risks. Radiation exposure. Mars lacks a strong magnetic field and has a thin atmosphere, increasing radiation risks. Limit time outside and use shielding. Psychological challenges. The isolation and distance from Earth can lead to stress and depression. A supportive crew environment and regular communication with Earth are crucial. Resource management. Efficiently manage limited resources, including food, water, and oxygen, with recycling systems and contingency plans for emergencies. 4. Return journey. Preparing for departure. Launch from Mars. After the mission, prepare for the ascent from Mars to orbit, where the return spacecraft awaits. Ascent to orbit. Use the ascent vehicle to launch from Mars' surface and rendezvous with the main spacecraft. Earth return. Return trajectory. The spacecraft will embark on a trajectory back to Earth, using gravity assists or propulsion adjustments. Re-entry and landing. Re-enter Earth's atmosphere using heat shields, followed by a controlled descent and landing. Post-mission recovery. Rehabilitation. After months in microgravity, rehabilitation is essential to restore muscle strength, bone density, and normal bodily functions. Debriefing and analysis. Participate in debriefings and contribute to scientific research by analyzing data and samples collected on Mars. Public engagement. Share your experiences with the public, inspiring future explorers and advancing humanity's understanding of Mars. 5. Future considerations for Mars colonization. Sustainable living. In situ resource utilization. Utilize Martian resources for water, oxygen, and fuel production, essential for long-term sustainability. Terraforming. Long-term plans may involve efforts to make Mars more habitable, though this is currently speculative. Ethical and environmental concerns. Planetary protection. Avoid contaminating Mars with Earth-based microbes, preserving its natural state for scientific discovery. Human impact. Consider the ethical implications of colonization, including environmental impact and responsibility for the Martian environment. Final thoughts. Traveling to Mars is the ultimate human adventure, pushing the boundaries of technology and exploration. While the journey will be challenging and costly, the potential rewards are immense. As space agencies and private companies continue to develop the necessary technologies, a trip to Mars is moving from science fiction to reality. Prepare thoroughly, understand the risks, and be part of humanity's next great leap into the cosmos. Safe travels on your journey to Mars. Thanks for watching. Kindly subscribe.